Morning, everyone. My name is Kafaro Gabdel, and I study from Coral Senior Secondary School. So today I'm right here to present to you just a simple practical of chemistry. So today we're going to talk about the evidence of particles in matter using liquids. So what does it mean? Like to the evidence of particles in matter using liquids, like to prove that are really particles in matter, are really particles of matter in liquids, are they contained in liquids? So today that is what we are, today that's why I'm here to present to you all that. So I will begin. As you see, you may wonder what's the little things that are in front of me. So as you can see, I will begin from this yellow container. It's just a potassium dichromate. As you see, it's a potassium dichromate. So we may need it in this practical today. So we also have the blue container, which is the potassium permanganate. Yeah, as you see. Yeah. So we also have the beaker of the maximum capacity of 150 milliliters. So we also have the slides here. There are two of them, and we also have the spatula. So all these are the laboratory apparatus, as you see. So our first step that we are going to begin with, I'll look at what we need. For instance, what am I going to need in this practical today? So here is my book, and as I read from number one, I need a few crystals of potassium permanganate. So as I've shown you from the blue container, we have the potassium permanganate. So they're just advising me to get a few of the potassium permanganate as we're going to carry out this experiment. So number two, we need water. So where is our source of water for now? So if you see on my right here, I've just got a tap, a laboratory tap. So it's what I'm going to use as my source of water, as you see. So this will act as my source of water as in our practical for today. So we need the second last thing that we need, or the last thing, for instance. So I will need a beaker. So where is our beaker for now? Our beaker, we shall use this will be our beaker that we are going to use to carry out this experiment. Yeah. So this will be our beaker that's going to help us. So all that, after getting to know all the instruments or the equipments that I'm going to use for my practical. So there are some procedures that are supposed to take we are supposed to take in order to come up with an accurate practical. So here are the needs, all the procedures that I'm supposed to follow. So procedure number one is saying to have filled the beaker with water. So what I'm going to do is to have filled the beaker with water. Here is our beaker, and here is our source of water on my right, as you see. So the maximum, as I told you, is 250 milliliters. So they are just saying to have filled the beaker with water. So where is our half measures? So our half measure is just between the beaker and here. The half measure is just 150. So meaning from 250, the half of 250 is just 150. So meaning I'm going to just fill this beaker to reach the extent of 150. That will be our half filling of water in the beaker. So let's do it. As you see now, I will just turn to the left of this tap. So when I turn the left, the water will start pouring. So when the water pours, I just drop this beaker below. The water starts getting into. So as you see, it's almost there. Yeah, it's there now. As you see here, it's now 150 milliliters. So in our procedures, they encouraged us to just have filled the beaker with water. So it's there. Let's move on to the next procedure. The next procedure is saying carefully add a few crystals of potassium permanganate in the beaker containing water. Yeah, so here is our potassium permanganate container. So they are just advising us to add a few crystals of potassium permanganate in a beaker containing water. Here is our beaker containing water. Here is our container of potassium permanganate. So I'll just get the container of potassium permanganate I need to open it and I need to just get out some of the potassium permanganate that I'm going to use so that I can put in our beaker. So as you see here, here is our potassium permanganate. It's kindly black in color, but we shall see our results after adding it into our half-filled beaker with water. So I'll just scoop it from the potassium container. I drop it here on our slides. So here our first slide, as I've shown you. I'm going to use a spatula to scoop it out. So let's do it. I'll use the spatula to scoop out this potassium permanganate. So as you see here, here is our potassium permanganate. As I told you, it's black in color, but we shall see the results after adding it to the water. So I'll just drop it here on our slide. Yeah, that's enough. I think this will be enough for us to carry out the experiment. So I need to close it, close our container. Then we move on to the next step. So as our step said, carefully add 2 crystals of potassium permanganate in the beaker containing water. So I couldn't have just scooped out this potassium permanganate directly to our beaker containing water. Instead, I have to first scoop this potassium permanganate. I drop it on our slides using a spatula so that we can get an accurate experiment. So as you see here, I'm going to just get this spatula, then I drop this potassium permanganate into our beaker containing water. So let me do it. So as you see, as I told you, it's black in color, but we shall see the result after adding this potassium permanganate in the beaker containing water. So as you see here, I'm going to do it. It's black in color, but let's see the results after adding potassium permanganate in water. So let's do it. As you see now, that's what I'm doing. So I'll just scoop, but before I scoop, there's something we first have to need to know about this spatula. This spatula has 2 sides. It has this flat side and this curved side. It's like a spoon-sided. So we have also this flat side. So for instance, when we are scooping out this potassium permanganate in its container, we need to use this spoon-sided because we can't use this flat-sided to scoop out any our substance, yeah? Because if we use this side, it may pour around. But if we use this curved side, which means it may be holded from the container to the slides. So for this side, for instance, it's used when you are just taking the liquid from one place to another, not from directly. Remember, this container it's not just flat, that it's not in open, yeah, it's not exposed to air, it's a bit curved. So I will use this. I'll use this, then like for now I can't use this curved surface because the potassium permanganate, or the substance that I'm going to just transfer, is just enough. For now it's in an open place, yeah, it's an open place, so it's good for me to use this flat-sided. So I can't use this curved-sided because this is what I used when I was picking the potassium permanganate from its container. So for now I'm going to just drop it from the slide to the beaker. So as our second step said, yeah. So let's do it. I use the flat-sided so that I can scoop this potassium permanganate to our beaker containing water. So this is it. Remember, it's black in color, so we shall see the results after adding it to the water. So here is it. Then it's added to the water. As you can see now, after adding this potassium permanganate in a beaker containing water, this is our results. So because the question is not yet done, we need to finish this question of ours. So as our third step says that swell the beaker slightly and leave it to stand. So as you see here, this is after adding this potassium permanganate to the beaker containing the water. So it gave us this result. So they are saying slightly leave it to the flat surface for it to concentrate. So as I've done it, so I will need to leave it like some few minutes. Then I will see our results. So that we can get an accurate practical work. So our third step is saying, sorry, our fourth step is saying predict what will happen if the speaker is heated with a burner. So for me, for now, we don't have a burner around here, but we can predict using some of the scientific theories, which one of them is predicting. So I can predict what would happen to this beaker containing this potassium permanganate with half-filled water. So in case if we had a Bunsen burner and we just dropped fire on it and we put our beaker above, so I predict that this water contained in the beaker will have changed and it will completely turn to purple color. But for now, as you see, at the bottom surface it's completely purple, but at the above surface it's not completely purple. It's a bit purple, but not yet in at the bottom it's completely purple, or it's somehow even dark. But I predict that if we get a burner, then we drop it to the bottom. I think all the substance, all the particles in this beaker will be like, they will increase, they will vibrate, leading them to expand, and they become so, which will cause this substance of ours to become completely purple for the entire of it. Yeah, so that's it. That's fine.